Percy Lang is one of the leaders. I know Feifei, but don't know Gripper that much. But there's definitely some of the people who are in that group. Yeah.
That's cool. Yeah, I took one of the crash courses on knowledge graphs a few years ago.
Oh, cool.
Which is really cool, actually.
Yeah.
Nice. Yeah, because I knew some semantic web stuff.
Right.
I wanted to see what people were actually doing.
Right.
And so many great people invited to talk, whether they're doing industry or research.
Yeah. No, they've done a really good job of kind of engagement. Yeah.
Very cool. Yeah, I tend to follow people's.
Yeah, Stanford is definitely a hotbed of thinking about that stuff right now. Between the people in computer science, the people in linguistics, and the people in neuroscience.
Yeah, that's right. Yeah, blending it. Yeah. It's got that multidisciplinary culture.
Right. The only problem is that all the CS people end up going and creating new startups, and so you can never get your hands on them, right? Because they're all busy, running their company.
Yeah, it's funny because we have the brain drain problem in Canada because everybody's going to the U.S. But you guys have the problem in academia because everybody's going to industry.
Exactly. Right.
It's functional where you are as well.
Exactly. Yeah. Well, it's like you walk down the street and a VC offers you $10 million.
Exactly.
So nice, yeah.
Because sometimes they are like much longer depending on what other things are happening,
I was very confused by that. I thought all the sessions would be an hour, and then it's not. But this one is.
When I was putting it in, I was like,
We're trying to remove that.
I made a terrible mistake, and then I double checked it.
We're in Ontario.
They just didn't give us an hour for all the sessions.
So we give it a nice name so
Right.
people want to come back.
Okay. Right.
There's good stuff in there. There's good stuff. There's actually a lot of cool stuff.
Right. Is there a lot of investment?
That's the problem. I mean, there is. There's better than probably other.
I feel like people are investing in my own thing,
Like Toronto's going to be a big deal, no matter you're not going to get that exact experience, but it's somewhere. People, our big one is
He did end up giving
the
them
big
all
co-op
to
positions for undergraduates out of university is the banks.
Interesting.
So the banks scoop everyone up as security analysts and app developers.
I don't know.
He just thinks he didn't get any answers. Yeah, and other
Yeah.
questions.
I don't know.
I mean,
If he didn't have the crowdcast open, then he would not have known.
Yeah, I'm not mentioning the
Because we're not streaming the room.
Second year,
That's true.
so that's when you start to catch people who are really standouts.
Yeah. Hi, good morning. I see it's 8 o'clock. It's another early morning at OHBM, but let's get started. Thank you all for coming this morning to talk about standardization of code. I'm sitting here at the table with 4 experts to talk about code. Next to me is Ram. He's at MathWorks. Next to him is Russ from. I see I made a copy mistake. I'm so sorry, Russ. Stansted, right? Yeah. Next to that is Francis from the Ontario Brain Institute, and at the end of the table is Tyler from SharkNet. I would like you all to quickly introduce yourself before we get this panel discussion going. For the audience, you can ask questions either on Crowdcast or in the app, OHBM app, which we'll monitor. So if you have any questions, you can ask it there. You can also raise your hand to ask questions to one of the panelists.
Yes. Thank you. Good morning, everyone. Firstly, thank you for making it this early in the morning. Also, it's my privilege to share the panel with all of you. My name is Ram. I'm with the MathWorks. I've been with the MathWorks for about 7 years. So MathWorks are the makers of MATLAB, Simulink, and 140 plus toolboxes. And in my role, I work with academia. I work with professors, researchers, scientists to help them make the best of what they want to achieve with our tools. So that said, a lot of the territory, the places I work with accounts range from Montreal, Boston, Massachusetts, New Haven, Connecticut. So again, a hotbed of neuroscience research. I've had a chance to rub shoulders with a lot of neuroscientists such as yourselves. And again, looking forward to the discussion.
Hey, Russ Poldrack. This can I guess so. I'm a professor at Stanford in Department of Psychology and Associate Director of our Stanford Data Science Institute. And my lab does a lot of work on software development. I might be the only person, I'm almost certainly the only person up here who started programming when you recorded your program to a cassette tape.
That's true.
Yeah. So I played in a lot of different, programming ecosystems, including MATLAB, but I've been a Pythonista for the last decade or so.
That's great. Hi, everybody. I'm Francis Jeanson. I hope everybody can hear me. I'm actually so I recently joined the Ontario Brain Institute, heading their Center for Analytics, which is a new initiative on their part, really seeking to leverage and maximize the value of neuroscience research data. So it's really exciting. But I've worked as a software developer in the past. I've worked, I have a PhD in cognitive science and AI, looking at neural processing, neural coding, and simulation. So working a lot with software, working a lot with data, but today in this, I think in the last decade, really working closely with a lot of researchers and labs, as well as with startups who are developing really exciting technologies and maximizing the value of the data, but developing really sophisticated code that is becoming increasingly sophisticated. So really excited to be here and share some experiences and thoughts.
Awesome. Hi, I'm Tyler Collins. My background is in computer science. I learned all of my neuroscience and everything like that after I finished my degree, so I'm still learning and all that stuff. I work as a developer and a consultant for EEGNet with Alan Evans and Christine Rogers, and I work on the Canadian Open Neuroscience Platform. My other job, I'm a high-performance computing consultant for the Digital Research Alliance of Canada, so if you run on any clusters like Narwhal, Beluga, Cedar, Graham, or anything like that, I help develop the scheduling policies, and I also work with researchers about how to take your jobs from okay, it's running on my MacBook on 10 subjects to I need to run 1,000 on the cluster. How do I do that? Lastly, I have a particular interest in EEG. That's what I help researchers with the most, in doing kind of advanced techniques, ICA, and getting that running on the clusters and all of that stuff.
Well, thank you all. So my name is Selma, and I have a background in developmental psychology. And that is maybe where my interest for this topic comes from, because I didn't learn anything about coding during my degree. And only when I started doing my PhD, I suddenly needed to write code because I also wanted to do some neuroimaging. I guess it's familiar for people in the room that we all have very different background and different experience with coding. And I really appreciate that the four of you want to share thoughts on this, because I think one of the things is people in neuroscience are expected to write code, use a lot of code, and especially increasingly journals ask you to publish your code as well. And I think some researchers might be very insecure about that and feel like they're not up to that. Other people might be highly skilled in that. So that is some of the things I would like to discuss with you. And my first question would also be, do you think that code should always be shared when you submit the paper?
Who's going first?
You want to give it a shot, Tyler?
I'll start with the hot take and just say yes. As even if it's just some sort of appendix thing or going into a repository that you link to in part of the paper, I think it's something that you need to stand behind as part of the publication, so it should be included. Yeah.
There was a piece in Nature around 2010 called something like "Share Your Code, It's Good Enough," and one of the points which I thought was I have the same hot take.
Yeah.
And one of the points is very few people who are scientists think their code is good enough. But if you think it's good enough to support the scientific conclusions that you're making, then it should be good enough to let other people look at it. And I think in part of the concern kind of comes from a culture of thinking, being afraid of what happens if somebody finds an error in your code. But ultimately, you would if you're doing something wrong, you'd kind of like to know that, right? Because you don't want to kind of promulgate, wrong ideas. But the corollary to that is we need to kind of normalize, feedback telling you that you're wrong, and not make it be like, oh, you're a failed human because you made an error in your code, but really you were trying to do the right thing and just happened to not do the right thing in this one place. That doesn't make you a bad human. It just makes you human, because we all make mistakes. So I think we do need to normalize that, programming as a, as a human activity where we all make errors and just try, and obviously we want to try to make as few as we can.
Do you have the feeling that code is checked enough online and people do get that kind of feedback?
In general, well, I think it depends. In general, no. So we had an interesting experience. We had put out a preprint that criticized a very large, well-known project, and they basically they dug in and looked at our code and found an error and got in touch with us and said, hey, you made an error. And it didn't fundamentally change the conclusions, but it changed the numbers substantially. And so we basically said, hey, the paper was actually under review. We really appreciated the feedback, right? Because we didn't want to get the numbers wrong. And so we had to tell the journal, hey, there was a mistake, here's a new version. That's the only time that I think we've gotten that kind of feedback. And we publish code with pretty much everything we do. So I think it doesn't happen that often.
I was just going to add, another thing that I think obviously publishing your code does is allow for reproducibility, right? And I think we probably,
I think you want to speak
Oh,
closer to the
sorry.
mic.
another important aspect of, oh yeah, I can hear myself. Another important aspect of publishing your code is reproducibility, right? And in science, I think that's something that we fundamentally want to do. I mean, that's part of it. It's because partly we want to check for errors and if there's mistakes in the code and opportunities to correct it. But it's also for the science itself. Like, do we actually want to rerun that process or that pipeline or that analysis and allow somebody else to do it again, maybe on another data set, or do it again with the same data set, so that we can double check and make sure that the protocol was followed accurately and that your results are what they should be. So I think that's another sort of very important complement is the reproducibility.
Yeah, I would also add something similar to what was said. I think we have seen, especially with a lot of these community toolboxes that have been created, that basically cluster up a lot of the functionality for specific applications like EEG, so on and so forth. There's definitely a lag between what was created and then when the error was found. There's a pretty large lag. I think that goes to your points that it's not regularly checked online.
Mm-hmm.
So journals quite often ask you to publish your code. What do you think the role of the reviewer is in checking codes?
Well, it's not the most rigorous.
Tyler.
It's not the most rigorous scientific test, but I think that everyone performs the eyeball test, which is glancing it over. That's where you should definitely start. I mean, like, part of this kind of that question leads me a little bit to the conclusion of reviewers that are requiring code. You're definitely going to have somebody reviewing the paper that has the qualifications, or else people are going to push back on that, right? Like, if you're sensitive about your code, and we've already acknowledged that everyone can be kind of sensitive about sharing this and going out, and it's scary, receiving that criticism, waiting for your extra reviewer, even on your normal manuscript or anything like that, right? So.
For once this interesting thing has happened, like in the last year or so, we got a set of reviews back on a paper, and most of the reviews were just standard reviews, basically talking about the paper. One of the reviewers said, I didn't really read the paper, but I went through the code, and here's a bunch of comments on the code, which was sort of interesting. I often ask for code as a reviewer, and I'll occasionally try to actually run it. Usually it's just like an eyeball test.
Yeah.
But I think one important, aspect of sharing code is increasingly, you can't write down all the details of what you did in the paper. So the code is really the method section. Right?
Yes, absolutely.
If I want to know exactly how you did something, I have to look at the code to find that out.
Mm-hmm.
Yeah, I think that's a very interesting point. So something that's touched upon a couple of times already is researchers being scared of sharing their code. What are your thoughts on how we could deal with that? How can we motivate researchers to share their code? What can we do to change that? Or help people at least being less scared?
I think this was touched upon, by Russ. I think as a community, it's important to realize, to propagate the notion that any code is worth sharing. It definitely furthers what you can do and what can be done with your code. It extends the value of your research. But I think in addition to that, there are a couple of other things that I think come to my mind, and I'm taking a lot from the ideas of open data. For example, how do you create multipliers in the community? How do you incentivize code? For example, you could have badges. We are seeing a lot of badges in journals for open data, open code. Can we have prizes? For example, I know OHBM has a data sharing prize, something along those lines. The other thing also to notice is, in terms of conversations I've had with junior neuroscientists and researchers, is that there's a lot of diffidence when it comes to sharing code because you're worried about what happens, as you said, when a bug is found, or what happens when there needs to be some tech support for someone who's using that code all over again. Will I be the single point of contact? And I don't want to do that, so I'm not going to publish my code, is their thought process. And I think in a lot of times when you talk about licensing, chooselicense.com, GitHub, the BSD, MIT licenses, I think it's important to note that you can specify, you can be transparent about the level of support you're going to provide going forward, and that's completely okay to do so. You can provide a lot of support, you can provide no support, it can be completely hands-off, and that's completely okay to mention. But I think taking these away will help incentivize more people to share their work.
That's good. I'll add something. Yeah, those are great points. I think I was going to add also sharing your code, I think, creates an incentive for others to use it and to actually look at your paper. So if you just publish your results, that's great. I mean, that's the sort of classic way of doing it. But if you actually provide your code as well, I think a lot of folks who are interested in what you've done, they want to be able to test it, maybe rerun it. And I think we're entering that day and age where it's, we have more of the early career scientists who are familiar at least a little bit with running code and running scripts and running analyses themselves. And by having code, at their fingertips just allows them to actually do that. And I think that in itself should be an incentive for the initial producers of the results and of the code as just a way to make to be more recognized and more appreciated for the contribution that they're making, because now they actually have not only just some results that seem to be true, but also a way for the community to, again, replicate it, maybe use some ideas from it, expand on it, which makes it a lot more exciting, and it also gives you an opportunity to create more of a community around the type of work that you're doing. So that should be an incentive as well.
I just wanted to add that, you don't need to be always contributing a package or some sort of wheel thing or a giant monolithic script. You can totally contribute things or include Jupyter notebooks, something that's your re-executable, run, start from the thing, be interactive in how you're learning it, running these things on any of the Canadian Open Neuroscience platforms, NeuroLibre, all these things with CBrain, and gluing everything together, right? Personally, when I'm working with researchers, often what I do is I start in Jupyter or a MATLAB kind of workspace thing, and I explore, and then I finally end up with a function or a piece of code that I'm okay, this is bulletproof, mostly. And then it goes off into another script and put into something. So that's a lot of what my workflow looks like personally.
Yeah, I think there's I'm probably guilty of this, as a kind of a reproducibility zealot of making it seem like there's all these things you have to do to be perfect, and it's important not to let the perfect be the enemy of the good, right? That,
absolutely.
There's a small set of things you can do that even if they're not completely buzzword compliant, with all the reproducibility goodies, they're still going to be really useful for other people in reviewing your work and potentially reusing your work. And so I think, kind of doing good enough is better than not doing anything at all. One other point I want to mention, which is kind of the flip side of the points that y'all were raising, is I think another thing that we need to help people feel more comfortable sharing their code is to have some way for them to get sort of pre-review before they actually put it out. Yeah. So, a lot of, some labs, in our lab, we do regular code reviews, but a lot of labs don't have, the expertise. Fortunately, the AI tools are actually pretty good at, helping with code review, with both improving code and potentially finding bugs. They're not perfect, obviously. But I think that's one solution, is just, for everybody to just run their code through, ChatGPT, just to make sure that it doesn't find anything, or at least see, if you ask it, what are the problems with this code, it'll be happy to tell you. And some of them may be wrong, but usually they seem pretty good, actually. And then also trying to build communities, even if your lab doesn't have, if you're working in, Julia or whatever, your lab doesn't have Julia experts, there's almost certainly on campus a few people who work in that ecosystem who might be happy to talk with you and say, look through, kind of do a little informal code review just to kind of give you some feedback. So I think that's another alternative.
I just wanted to add something. When I hear reusable, I always think about like the broader community in reusable, but my lab size personally, when I was doing my degree, was one. I was in a lab with one person, so there wasn't a lot of reusable there. But the work that I do now, the lab is 10 or 12 people. So you don't have to think about reusable as the, all of us in the room here. You can think about reusable as the brand new undergraduate, the little person coming in who has no idea, and you give them your paradigm. Like it should be reusable to your local people too, and supporting that so that they don't have to reinvent the wheel, and then that's something that is going to spawn errors between publications and things like that.
Or, for that matter, even yourself a year from now.
Absolutely.
You're not going to remember what
No,
you did.
absolutely. I never do.
Something that was briefly touched upon by you is whether you have people in your lab that are experts that can help you check your code, or maybe not even experts, but lab members that can help you check your code. And one of the things I've been thinking about is, should labs have that? And if the answer to that question would be yes, would that only benefit labs that get in the big grants or universities that are rich? So I can see the advantage of hiring people specifically to help out with code, but would that also just be more unfair? I'm just curious not if you want to answer, but any of your thoughts on this.
Yeah, I mean, I'll answer as somebody who has 4 software developers in my lab. Obviously,
I wish.
I'm lucky in lots of ways. Stanford the U.S. is a rich place. Stanford is a rich place. Now, none of those people was hired to help other people, with program. They were all hired to work on software development projects that have to, generate products. But they are all there if we want to ask questions of. So we're lucky in that sense. And that's why I was kind of getting at building communities. Obviously, there might, depending on where you are, the community might have to be broader. Just sort of, you might have to look across your country or something like that. But I would hope that there would be a small enough set of people, or a big enough set of people that you could form a little group to to start talking. But I agree. I think it's a concern that hopefully community building can help us switch.
I can just jump in with that, and how I started in neuroscience is actually just like needing an undergrad thesis in a project, and I got contacted essentially by the neuroscience and psychology department just because there were friendships between professors at my institution. So if you're a PI and you're looking for like consultants on this sort of thing, like ask the co-op department. You can get co-op students. You could get somebody looking for just like a summer project, any of those things. They'll be happy to work on something that, like, brains are cool, right? So computer science people will be very happy to work on this stuff.
I was going to add, another way to maybe look at it is also look at your own communities, right? Look at who you're working with and who you're funded by, or what are the other sort of organizations that are affiliated with your own that might have experts in working with the type of code or the type of software that you're working on. And there may be an opportunity to create sort of that, what you call community of practice. And so, like with the Ontario Brain Institute, they fund research in neuroscience across a diversity of brain disorders, neurodevelopmental, epilepsy, cerebral palsy, depression, neurodegenerative disorders. And so you have experts, some of them highly technical, very, very software savvy, but working only in that brain disorder area. But what we're working on is actually creating a bit more of a community across, so that they can actually get together and start talking about these challenges around either data preparation, data curation, or even data analysis, and ultimately, I think, software as well. So it's kind of an emerging area, but I think that idea of community of practice, looking like what is your community, who is available that you could potentially reach out to and start forming something, could be another way to address that challenge if you don't have the funding to hire your own software engineers.
Yep, I'd like to add that there's definitely a lot of cross-pollination through these kinds of communities. I'd highlight that a lot of these communities, part thanks to the COVID era that happened, have been a lot of it have been online. It's not necessarily there on-prem. It's not necessarily there on campus. You'll notice that it's across the world, and a lot of it is being bridged by the online platforms that are available to us. The other thing I'd also like to highlight is a professional software company like MathWorks. They spend millions of dollars, a lot of manpower, a lot of time and effort to make sure you have expansive test suites to make sure your code doesn't regress, so on and so forth. it's not fair to expect someone from a lab. We're not going to hold them up to the same kinds of standards. But at the same time, some level of standardization will be helpful. And I think that's where, having a community to have this kind of framework to work from would be helpful.
Can you maybe elaborate a bit more on this adaptation of standards? How would you, do you have any ideas on how you would reach that? And how you would help people, researchers, to do so?
I always call these kinds of decisions religious decisions, and when it comes to standards, pick one. Just pick. Do not have the analysis paralysis. Don't overthink it. If you're doing neuroimaging bids, just do it. It's fine. It's going to be okay. These sorts of things, like that's when it comes to MATLAB stuff. You have the automatic formatting stuff. If you run in Golang or anything like that, you have GoFmt or format that stuff. You have for Python anything with the VS Code linters. You have all of that stuff. The important thing to do is to just pick one and follow it, and you don't need to have a reason. It's okay, right? So that's what I would say for arriving at these standards. If you're a PI or if you're like the programming person in your lab, just pick it. Just pick any one. It's totally fine. And you can switch between standards fairly easily because it's just a text processing problem at that point, and that's relatively easy. So,
Right.
yeah.
Along the lines of the religious decision, I think that the reason to pick something, the best reason to pick something is that it's the thing that the people around you are doing,
Yeah.
right? Because you can ask them questions.
Yep.
I think it's also important that that's a good way to get started, because I think it's important that we have as low a barrier of entry as possible when we're having these standards. You don't want to get someone bogged down with the amount of standards, the amount of reviews, the amount of testing that's required to get started, and that's going to prevent a lot of people from coming in. So the lowest possible barrier, in many ways, what are people around you using, continuing to using that so that you have some kind of support would definitely help.
I was also going to add, I think you have to calibrate the level of testing and the standards to the problem, right? If the problem is trying to build a package that you want people to go and use, right, then you need to put a lot more work into testing and validation and that sort of stuff, right? If it's for a particular scientific project, then you want to make sure it's getting the answer right, but you're probably not going to go write like unit tests for every little thing that you've done because you probably haven't modularized it. But you want to at least maybe create some simulated data and make sure it gives you the right answer when you give it data with a particular answer built in.
Yeah, to that point, I also would encourage again any sort of researcher, when we think about actually how we're designing these things and in our paradigms and any sort of a hypothesis, maybe also try and give a thought to how you're going to write the actual code and test these things. If you're going to do less than 100 subjects and it's only going to take a couple hours and you don't get to use the workstation at your lab for the weekend, don't put as much time into optimizing all the code. Just do a little bit of testing, but be aware of that. But if you're going to submit it to the cluster, please, on my behalf, please test it and check the memory efficiency and do all that. And yeah, you'll learn and you can submit tickets and people will always be very welcoming and help. But definitely consider that as part of your study design, what the analysis scripts and those kinds of things are going to look like.
Mm-hmm. Yeah, I can add a little bit to that. I think the concept generally that I would follow and recommend is don't over-engineer. Mm-hmm. It makes me think of what you're saying. Don't overthink it. And I think as you start to get savvy with software development or programming, you start to want to automate everything, and you start to want to write scripts that do everything for you. But you end up taking more hours writing the script than you do if you actually did most of it or half of it manually. So think about efficiency, think about time. Don't over-engineer. There's also the problem of we call essentially it's you're creating overly engineered platforms that you then have to reverse engineer or you need to refactor, and that can be a problem too, especially when you're getting to a point where you're building something that's more substantial, more of a pipeline that you need to run again and again, and so again, yeah, keeping it simple, a bit like to Tyler's point.
Create something that's maintainable.
That's maintainable and simple.
Thank you. We talked a bit about if you choose something, just stick with it. That's something you suggested. I was wondering, just from your personal experience, not necessarily anyone's personal experience. What is great coding tools that you use? What is libraries that you have good experience with that you would recommend?
My first kind of main, like what I learned in my undergraduate was Java. I don't use Java anymore. It's okay. Anything with EEG Lab and those sorts of things in MATLAB is what I use the most there. I've mostly switched over to Python in MNE for my day-to-day in parsing things, and PyBids, those sorts of stuff for data sets. My workflow is like VS Code and Jupyter Notebooks and most of that sort of thing. Any extensions as well for linting, just basic stuff. I actually don't use Copilot or any of those sorts of things. I don't like I don't like the text jumping out at me as I'm going. That's a personal thing. If you like it, that's fine.
I love it. I've been using Copilot for like a year and a half now, and I think it's amazing. And it actually makes programming more fun for me, because there's, sometimes you'll get to a place where there's like 20 lines of code that need to be written, and you know how to write them, but it's kind of drudgery to write them.
Yeah.
And Copilot almost always knows exactly what you want to write, and you just like tab complete, and it's done, and you can go on to doing the fun stuff. So I'm a Python VS Code person as well, living in the ecosystem of like, scikit-learn, nylearn, and trying to think if there's any other. I mean, all the thing. One of the things I like about Python is the ecosystem of kind of like tooling around linters and formatters and all that kind of stuff. I'm sure they exist in all the other languages as well. But I would certainly suggest trying out whatever the relevant AI tools are. You have to be careful with them, but I think they can really improve your productivity.
I would also add with Copilot, the ability to help you document is also really cool. I think there are a lot of benefits of Copilot. On the MATLAB front, I think just a few things. I think there is definitely a trend of low-code, no-code kind of workflows, and you'll see a lot of this being enabled through through notebooks, through apps, user interfaces that let you perform, tasks very quickly, and then they generate code for you. A lot of these workflows are seen, like, for example, the Jupyter Notebook equivalent is MATLAB live scripts. The ability to call MATLAB from Jupyter Notebooks is also pretty cool. A lot of apps in the world of AI, classification, regression learner, whatever you're trying to accomplish, to do it visually first, get your result, and then have the language write code for you without you having to be bogged down by the details.
Related to that, it was already mentioned before, putting your code in ChatGPT. What are your thoughts on that?
Do you want me to start with the hot take? I don't personally I don't use it. I don't start with ChatGPT or using those sorts of things. I agree with the idea of putting it through at the end or everything like that, but I don't like the low code, no code things. Everyone here, you're the expert in the field. You writing the code is the ethical thing of you looking at it and making sure you know what's going on and what's being done with it. I mean, the side thing of that is I copy from Stack Overflow all the time. We're all human. We all do the same sorts of things. So, personally, it's hard for me to let go of that feeling of control of writing every single line of code and owning all of those lines. I mean, I don't think there's anything wrong with you generate it and then you're actually carefully reading it yourself, but that becomes an important step in my opinion.
Yeah, no, I totally agree. Well, it depends on where you are, right? If
Yes.
you're a complete novice and you just can't figure out how to do something, going and asking ChatGPT how to do it and taking that code and using it, I think is better than not doing it at all, right? Than giving up, right?
Yes.
So I think it can be a useful tool. My workflow, the only time I go to ChatGPT is when I need a one-liner or when I need a regular expression.
Yes.
Python regular expressions are impossible for me to keep in my head. I don't need to anymore because ChatGPT just gives them to me.
Absolutely, exactly the same.
But I don't, I think that having it write de novo large amounts of code, I think is not great, but helping you figure out how to solve problems. I mean, even if there's all these new kind of prompting strategies, right? So even if you don't have it write the code, telling it what the problem is and saying, don't write any code, just tell me how would you structure this problem. I think that as an assistant for just thinking is useful. But ultimately, you want to understand what the code is doing. I've played with Code Interpreter, which is the no-code tool in ChatGPT, and it's, it just gets things wrong. And unless you know what you're doing, you don't know that it's getting things wrong.
Yeah, I tried using it to write some sort of visual working memory task in CyclePy and was telling it to counterbalance a couple of different stimulus, and it ruined the count completely. So it would have been totally invalid.
And I think at this point, a lot of our use cases about ChatGPT are definitely evolving, as you correctly said. Talking about control, the Tesla autopilot, a lot of us know about it. I don't know how many of us trust it. But having said that, I think there are a couple of things. One is with the idea of ChatGPT, at least for now, we're seeing a lot of people using it as a way to get away from these drudgery-related tasks, tasks that take you a lot of time. You know how to do it, but you'd rather have it do it because, as you said, 20 lines of code, I'd rather have it write it for you. And that is something we're seeing. The other thing is the potential of where ChatGPT could go. The text representations, a lot of, when we talk about FAIR, it's not just about human readable, also machine readable. And a lot of times, if open code is available for ChatGPT to be trained from, what does that mean on the large scale of things? Do we need, again, are we still talking about standardization being very key? Because, as you said, it can throw out wrong results, it can hallucinate, and then what happens to our code, right?
One thing that I want to add, so we have a preprint that came out a few months ago looking at AI-assisted coding, and one thing we were looking at is like how well it can help you create tests. And it doesn't, you can't trust it completely to write the test because it gets the test often fail. You don't know, was the test wrong or the code wrong? But if you don't know how to write PyTest tests and you basically give it some code and say, please generate test for all of this code, it will very quickly give you a bunch of tests that you can then go in and like double check and tweak, and you don't have to do the drudgery of like actually, creating all the test framework.
Yeah, that's exactly what I used it for recently. I wanted it to create like a synthetic 16-channel EEG recording using like a NumPy array, and I said, give it muscle artifacts and give it eye movements and these sorts of things. And the only mistake it made was millivolts versus microvolts. So then I changed the unit and we were good to go. Like that's the only thing. So yeah, it's perfect for that.
I think one thing I'd also like to add is, a lot of ways we are looking at ChatGPT as a very smart friend. And even if it doesn't, write code for you, the idea is it can still help you learn a lot of coding practices. Like you said, help me write the algorithm, the pseudocode, help me get started. And it's been doing a pretty good job. At the end, the final sanity test has to be yours, at least for now. But having said that, it definitely does help you with the learning process, automating tasks that you could do, but it's probably going to do it faster.
Yeah, I was just going to add on the GPT side is, or LLMs in general, is I think it's also, you have to be wary of where your code's going to be applied and how it's going to be used. So the purpose of the code. If it's purely in the lab and it's purely for like sort of experimental reasons, completely fine. Use it, leverage it. I think especially in the context that the panel has been talking about so far, where you're asking it to do very specific sort of narrow tasks or helping you maybe generate some synthetic data. Where I would be more wary is if you're actually deploying something in sort of production pipeline, especially in those circumstances, or even something maybe up front where you have some sort of pipeline and you're generating some code, and it is part of a larger sort of platform where you have multiple stages, and you're sort of making code available or generating this code without proper validation and very careful scrutiny. I think the CSA, the Cloud Security Alliance, recently did something more. This is more about the security of the code, but found that about 40% of GPT-generated code had some vulnerabilities in the code. So obviously, from a security standpoint, can be also something to be wary about. So I think also think about the purpose and what you're going to be using the code for. But overall, it can definitely be a tremendous, I think, accelerator of the process of software development, and it's probably going to get better as time goes by.
Thank you. Apparently, there's also already quite some questions in the app. So, Andrea, would you like to share them with us?
I'll actually stand up so you can all see me and hear me, hopefully. So I think there's amazing questions there, and you already kind of have answered most of them, I feel. Because we're talking about ChatGPT, people are quite interested in a way how to then kind of recognize that you're using these tools. Should we cite them in our papers, for example? And are there potential risks with copyright infringement, potentially, if we are using them?
Well, I can jump quickly. That is a tough question. I think the organizations who release these tools are aware of that as well, and I think they're under pressure to probably review some of their strategies there. from what I can tell. I don't know. It's a good question, though. There's certainly the issue of potential copyright infringement, or at least appropriation of some of the code. I think one of the big concerns is around how when code is generated from these tools, are they perfect copies, so to speak, of code that already exists, and they're not, and you're not citing that code, even if it's an open license, and that's a legitimate concern. A flip perspective, another side would be to think of these LLMs a bit like humans, right? We all are, if we're coders, we're all exposed to other people's code, and we might reproduce patterns of code that others have taught us, so to speak, through their code that they made available as open source. So, there's that other flip side of the argument. But it is rather tricky, and I don't claim to have any answer, but it's important to think about for sure.
Yeah, I just wanted to say that, I think there's no, official legislation or, full rules or anything yet for, any country or, huge body to follow. It's still all being actively figured out right now. So I don't think there's a satisfying answer.
I'm not going to ask for a show of hands to embarrass anybody, but I wonder how many people have ever copied and pasted code from Stack Overflow straight into code that they're using in their projects. Exactly. Without citing this came from Stack Overflow, right?
There is a license on Stack Overflow. That all code is supposed to be licensed as an IT. So
Okay.
you know that you're supposed to give proper attribution. I'm sorry, the author of the question.
Right.
No. This is audience questions.
My point in this question was more my personal reason why I'm not using these tools, although I completely agree with the usefulness, the perceived usefulness of it, is that I can't comply with the license that is behind it. So, and there are rules. The rules are clear. If you derive anything from this code, you're supposed to either give proper attribution or whatever the license body of that initial code was. With LLMs, I get a piece of code, but I have no idea how to give it proper recognition and complying with the initial license.
Right. Well, that's the currently under litigation in the U.S. at least, right? Because Microsoft and OpenAI claim that it's fair use, at least under U.S. law. And yeah, so judges will decide that at some point.
And I was just going to add to Francis's point. I think this is a gray area for a few reasons. As Francis correctly said, as people, when we look at, different code, we look at different papers, research papers, we come to our conclusions, we identify these patterns, knowingly or unknowingly, we come to a conclusion and then we publish our own work. If ChatGPT does the same thing, that's the gray area. Do we know where it came from? Is it the same kind of inspiration? Then whom do we give credit to? Do we ourselves, when we do it, do we give credit to someone? And I think these are kinds of questions, exactly, right? We should. And I think that's where these conversations come up when you have these gray areas, where it's much harder to figure out when there are more of these soft decision making that's being involved.
Yeah, and maybe we hold these systems a bit more accountable, so to speak, because they're machine systems that can technically track, or should to some extent be able to track the sources of the information that they get their knowledge from. It is highly complex, as anybody who's a little bit familiar with neural networks, as to how they encode this information, and it could be challenging. But I know some bodies, I think in the U.S. actually, the National Telecommunications and Information Alliance is proposing the use of something like a software bill of materials, a bit like what's used in sort of logistics for materials and transportation, to actually create this sort of formal list tracing sort of the sources of the code, almost by line by line, of where this code comes from, what libraries is it making use of, the versions of those libraries, but in a much more sort of detailed and sophisticated way. And I think it's just in the sort of initial stages of discussion and formulation through these bodies of experts also around the world. But this is from the U.S. based NTIA, and I think there's a few others probably in the world considering similar ideas.
And a lot of what makes this challenging is the idea that AI in itself is a black box. We don't know, it's a lot of magic that's happening under the hood is how you'd see it. And I think that's where a lot of the challenges are from. I mean, you talk about digital health, you talk about, health providers using AI. There's a lot of diffidence for exact reasons. You don't know what's happening under the hood. Can you trust where the decision is coming from? And how is it coming to that conclusion? And that's where, there's a need for explainable AI. There's a need for interpretable AI, so on and so forth.
I think that answers your question. Is there
Hopefully,
more
yes.
online questions?
Many more. Some people, well, a lot of people actually, because we can vote on the questions, are interested to hear your thoughts about open science and whether it's aligned with using licensed code. So kind of a code bases that are behind the paywall and what might be the benefits or downsides of doing that.
Hot take, you can't do open science using closed code.
Is it still a hot take if I agree? I think that's what we should hold ourselves to. So we'll start there, and then sometimes you make exceptions, but it sucks. But we should try.
But if you push it forward and you say, I might not be willing to use a software that I have to pay for example.
My hot take includes that, yes.
It spirals, like for software that you have to pay for, it's not always visible. So like, for example, I have a site-wide license for MATLAB, so I get MATLAB for free. But as part of my high-performance computing stuff, MATLAB needs to run on the cluster. So there's two options. Either I convince the sysadmins to do a port forward so the licensing works, or I install the MATLAB runtime, which is challenging for the average. It was challenging for me, and so.
Yeah, and I think a lot of times when you talk about open science, even with FAIR standards, it's not necessary that the code is, it's open or it's free in that sense in terms of use. But I think what's important to think about from a workflow perspective is what you create from all the way from data to your analyses to your code to your results. Is it easily shareable? Is it easily reproducible? Can you share it with people? Is the code that you're writing, everything under the hood, is that available to everybody to share it? In fact, speaking of MATLAB, I'll just give something that happened about just a week back. So now we have the capability in MATLAB. Anything you write in MATLAB can be shared with anybody globally, even if they don't have a license. So they can view it, they can edit it, they can make changes to it, so on and so forth. So for example, we have the Brain Observatory Toolbox, which is basically lets you interact with the Allen Brain Observatory. The idea being here that, there is MATLAB code, it's basically open data, open code. All of this is available on GitHub. And at a single click of a button, anybody around the world can actually literally make changes to it, view it, and run it as well.
Interesting development. Thanks for sharing.
For sure. So the next question, people wanted to go back a little bit to the actual publishing your code with your papers, for example, and especially if the goal is reproducibility and having someone check your code, it kind of implies a data traveling with that code. Do we think that actually sharing the data, open data and open code have to go hand in hand?
It should.
There's a benefit to it, yeah, definitely. Related to that, I guess, yeah. So I mean, some journals will actually support the publication of data. Well, I'll mention one. Springer, Nature, Scientific Data is a candidate for that, but there's quite a few others. But it's a movement which I think is actually really exciting to see. Is that push towards making data obviously publishable, not just the results of some analysis or some scientific hypothesis, but the data itself, which creates more incentive for those who are working day in and day out with data and generating data to actually be able to publish that data. And if you could do the same for the code, I think that's phenomenal, right? We're creating an opportunity for those who create the code to also be recognized for their work, and to combine that together is certainly even better. I was just going to mention, and I'm sure a lot of you are familiar with this concept of FAIR for data, definable, accessible, interoperable, reusableness of data. And it applies really well to software as well. So can we make software more findable so that we can, make use of it, et cetera? Can we make it more accessible, interoperable, so it adopts standards that we talked about earlier, and so that you can combine and build larger and more interesting software? And can you reproduce? And we've talked about that since the beginning, but those FAIR principles are pretty nice for software as well.
Totally agree. Yep.
And I'd add that of late we're seeing definitely a paradigm which is called example-driven development. I'm sure you've heard of test-driven development, domain-driven development. The idea with example-driven development is it's pretty simple. That when you're sharing your publication, it's always nice to have a little bit of data, code, and that kind of blends itself into an example that can then be shared. And this kind of helps people kind of see a use case of how that data, what is the context around that data, what is the context around that code, and then they can apply it much more easily. And we've seen that this has increased, this potentially can help you increase the number of citations, bring more users into to use whatever you create, so on and so forth.
Perfect. There's plenty of questions, but I'm going to pick one, take the liberty, because this really applies to me as well. So the lack of formal training in software engineering is a real challenge, and challenge in general in research as well. So how would you go about addressing that?
I'll speak to it. No matter what you do, you have to put the reps in. It's time spent working on problems. There will be agony. There is suffering. I've been at it for 15 years. You know, I lose an entire day to a simple bug. It's just going to happen, and like dealing with that frustration is kind of like a personal thing. But you have to like just get the time in. And for me personally, when it was learning, it was giving myself like projects that I wanted to complete that would force me to learn a new tool or a new thing. So a really good motivator in academia is, of course, I need to finish my thesis or something like that. But I be project-based in how you learn these things and go about like exploring new tools.
Yeah, I mean, I think, you know, learning to code is just like learning any other hard thing that we learn, learning a new human language or learning a new musical instrument or whatever, right? It takes time, and not just like time, but, you know, time deliberately trying to get better, right? If you want to, I was trying to learn to play piano last year, and, you know, like it's just drilling. Like you just have to like do kind of boring things over and over. And it's actually less boring to learn a new programming language than it is to learn to play piano. But I think part of it is you have to actually like seek out, how do I get better, right? Once you've like gained initial skill, and that, you know, go on like Code Wars or, you know, one of these Code Kata type websites and just try to do coding problems.
Yeah, and like exactly to your point, like practice is different than play in an instrument and in these sorts of things. And yeah, like go, even if you're not in like doing the project thing, there's tons of YouTube channels out there that do like coding things. Put it on your side monitor while you're doing something else and just absorb that way of thinking, because for someone with a lot of experience, the language doesn't matter past a certain point, right? It's just a way of thinking, and your Google searches turn into, how do I open a file again in MATLAB? And it's not about like, what do I need to do? It's about like, what's the syntax? I forgot what an if statement looks like in Julia. Oh no, right? Like that's a normal thing once you get to a certain level. And yeah, just kind of trying to immerse yourself in that way of thinking in those videos.
I would add that absolutely you need to put in the hours, that's true. But I also would add that there are definitely smarter ways, quote unquote, smarter ways of doing it. You know, we spoke about ChatGPT. 10 years back, MOOCs were not a thing, YouTube videos were not a thing. So there are definitely more avenues for you to explore. And there are companies like MathWorks itself, like if there are challenges you're facing in terms of, you know, applying MATLAB to any kind of to your domain, reach out to us. You have access to engineers such as myself. You have technical support, and we can find ways to build a community around it.
If I could add one more thing, I think that like I'm not trained as a software engineer, but I've spent a lot of time in the last decade trying to learn a lot about it. In part because I run a shop with a bunch of people doing it. But you know, from my standpoint, one of the most important things about good software engineering is building things that are sort of readable and understandable and clear. And that doesn't mean putting thousands of comments in the code. In fact, writing really good code that doesn't need comments is much better than putting a bunch of comments into unreadable code. So there's one book that I always start by recommending. It's this book called The Art of Readable Code, which is kind of like a language independent. Remy seconds that recommendation. It's not 1,000 pages. It's a relatively short book. So if you're going to start anywhere, like learning how to write better code, that's the place I would start.
Another one.
Yeah.
There's a programmer's brain, which also helps the art of writing code with actually just the cognition part of it.
Oh,
So
interesting.
that was the programmer's brain?
Yes.
Okay.
It's a very good book.
Cool. Thanks.
Yes, perfect.
Those are all really useful inputs. Thanks.
Yes, for sure. For sure, very interesting. It just requires hard work, as everything. What you were describing is maybe quite solitary in a way. Is there a way for kind of more community-based, people getting together, learning together? Shameless plug, for example, hackathon type.
Yeah, I was going to say the
events.
hackathons, and that's getting involved in those community things. Like there's those machine learning things. Those are kind of fun because they give you a nice solid answer. Like they're meant to have a pattern that you can discover in them online, all those things. If you really like, I used to really like my first and second year, computer science programming assignments. It was like, okay, make a word search solver or something like that. Any of the big universities these days have like those open courses or the assignments posted or something like that, and just go look at the assignments from 5 years ago and try those and go from there. That doesn't really solve the community thing, but it definitely would help to find a friend and be learning at the same time and bounce ideas.
There's some great examples I've seen from industry as well, is actually what you call sort of pair coding, and I think there's other words for it, but essentially you have two developers working side by side, looking at the same screen. Sometimes they even have like their own keyboards, but both connected to the same screen and looking at the code together. And some companies actually opt for that option because it reduces the actual amount of errors that are produced in the code, reduces the amount of time that you need to then do code reviews and validation, et cetera. And these two developers work literally side by side, like during the day. Somebody starts to write some code, and then the other provides some comments and feedback, and then maybe they'll start writing some code, and then the other one will jump back in and provide feedback and comments. And it seems that this sort of paired coding approach seems to be a really effective way of producing high quality code. For sure, these are typically experienced developers who've been hired on to work within a software industry, but they can often be even sort of fairly junior coders who are also learning sort of the ropes and learning the tricks. And so that might be something effective as well. I haven't really quite seen that in the lab setting yet, but it could be something to explore and maybe test.
Yeah, I think in addition to a lot of good points here, in addition to what was said we said a lot of times we use code from Stack Overflow, MATLAB answers, so on and so forth. Maybe contributing back, and there's no dearth of questions. There are always questions about certain applications, workflows, use cases. Contributing back, testing your knowledge, getting feedback. You may not get feedback, but getting feedback on it is also a good way.
Thank you. The brain hack was mentioned, or a hackathon in general. And I think for quite some young research that I know, the idea of going to a hackathon is really scary because they feel like they're not up for it at the start of it, so they just won't go or won't sign up. Andrea, you've just been to the brain hack. Can you maybe say a couple of cents about how that is for people who are there for the first time?
Yeah, of course. I mean, that's why I kind of brought it up, because I thought it was a very amazing initiative for people coming together and working these kind of project-based assignments where you still felt like you were achieving something and you were learning so much at the same time together with other people. So if you guys thinking about joining us for the next year or year after, we would be happy to see you and kind of help us make it a very good place for the community to get together and learn and develop the open science together as well. Brilliant. And so I think we still have time for one more question, because it was brought up a lot about, okay, yeah, it's a good thing to share our code. It's a responsibility to us to share it. But people are bringing up a question of recognition. So writing a good code, sharing a good code is not always, well captured in all the indices that people and grant people are looking at. What is in your ideal world, a way to actually acknowledge the work that goes into developing a good code. And on the other way, if we are asking reviewers to review the code, is there a way we should recognize that as well? It's a difficult question, yeah.
Yeah.
It's an open-ended kind of question of what we should do and how we recognize good faith people updating these things. I think we spoke briefly about badges, about things in publications. Me personally, for the stuff that I've helped out on, I mentioned in the acknowledgements, kind of alongside the grant things, saying in Canada, like, okay, here's the NSERC number, thank you, and then I'm somewhere under there. That's my personal thing. I've never written a large-scale grant thing, so I'm not sure how that would go personally, but I think, again, that reviewers of journals, if they're going to start requiring this, should have an expert being the one reviewing these things. And yeah.
I'll just add, there's a growing idea of putting this, any of your open science activities onto your CV. So I basically, for each paper on my CV, if there's data, I have a link to data. If there's code, I have a link to code. If there's a pre-registration, I have a link to that. So you can do it that way. You can have a separate section that's like open science activities. So I think just making clear that you don't need permission to do that, right? You could build your CV however you want, and putting all of your open science activities there kind of brings them to the fore.
Do you think that's something that is recognized by a hiring committee?
I think it varies. Certainly the ones that I'm on, yes, but I live in a bubble, right? I think that in some ways doing it will make people, if people start seeing that, then it's going to start, people will think, oh, hey, that's something that's important.
You can also talk about it yourself at the actual interview, and that it's an important thing to you, right? That it is part of your identity in that way.
Yeah.
And for journal papers as well, for articles and publications, I think behooves sort of PIs to actually include code contributors and software developers in the authors list. I think most of projects that I've been involved in, developers have always been included. And I think that's a great way to recognize their contribution as well. And I don't know if that's always the case, but I think it should be the case.
I think the second part of the question was, how do reviewers get an incentive to actually look at codes? I think that's the last thing we can discuss now. If you have any ideas on it.
That's a much harder one.
It's really hard.
I think that, some journals, like medical journals, some have paid statistical editors whose job is to review the statistical part. It's not clear to me you're going to get really good, detailed review of code by reviewers in general. I think journals are going to have to pay somebody to do that probably.
Thank you. And thank you all for great insight in standardization of code, sharing your thoughts. Thank the audience for great questions. There's many more questions for which we don't have time now, but at 12:15, we'll have a table talk in this room as well. The speakers will be there, but it will be a more informal talk where you're very welcome to discuss this further. Thank you.
Thank you.